Top 10 stair building videos for 2023. Let's start with number 10. In this video, I will go over some of the options you will have if you're going to connect a stairway to a floor framing system with TJI truss joist. And there's not a lot of information on this, so I think the best thing I could possibly suggest would be to use some type of a structural beam, not a piece of construction standard lumber, either a rim joist or some type of a engineered product that the manufacturer would recommend when building these types of floors. And for the most part, we're going to be toe nailing the stringers into a ledger or into a beam, into something, and in nailing a ledger if we're going to use one into one of the other framing components, like the wall framing studs, a beam, or the truss joist. So here's one way that you can do it with a structural beam if you have a situation like this. Another way would be to use the rim joist that is going to be provided by the manufacturer. And again, we would be in-nailing the ledger into the floor framing system or even the wall framing and toe-nailing the stringers into the ledger. If we don't want to use a ledger, we could always make the stringers a little bit longer and then use some type of blocks between the stair stringers. Or we could even extend the height of the wall. I've seen this done before and don't see why something like this wouldn't work with most floor framing projects using truss joist. And the only thing I don't really like about top flange hangers in a situation like this, where it's going to be a high traffic area, is that it could produce a gap between the bottom of the floor sheathing and the top of the floor framing, irregularities in the floor, and of course squeaking in this area. And I know some people are like, no, it's not going to be that big of a gap. However, I have seen it cause problems before in these areas. And don't forget that you might need to check with your local building authorities, structural engineers, or building designers to verify these framing methods. Next up, let's go ahead and install a double truss joist. And according to one of the manufacturers, you will need to install backing and filler blocks, which might require a strip of plywood or OSB in between the bottom and the top chords to use a double truss joist like this. Now, I did notice that the manufacturer also suggested that you're going to need to figure out if the double joist will support the concentrated load from the stair stringers. And of course, I won't be able to provide you with that information. However, I will be able to provide you with what the inside filler block would look like. And in some cases, it might just simply be a 2x6 or a 2x12 to create more or less a solid beam, something that we will actually be able to put some nails into to connect our stringers to the joist. Now, this is a method I've actually used before, so haven't had a problem with something like this. However, this is a method that I haven't ever used, and that would be to use some type of building hardware. And this is actually one of the recommendations from one of the larger product manufacturers of truss joists. However, they did not provide us with any recommended building hardware that we could use to attach the stringers to the double truss joists. So again, you might need to check with a structural engineer or local building authorities for some type of a hardware recommendation. And like I mentioned earlier in the video, I think what an engineer or what the product manufacturer is going to be hoping for is that you will be able to attach this to either a rim joist type of material or some type of an engineered beam. Next up, number 9. This is part 2 to a video that I made. I will put the name and a link to that video in the video description box. And I think I figured out a way to have both what I would like to see, which is something like this, and the design you're going to see here in a few seconds. For those of you who believe that this design right here won't work for you because somehow the stringers are going to slide forward even though they're nailed and securely fastened to some base framing plates that are securely fastened to the concrete, or base framing plates that would be securely fastened to a wood-framed floor. Because either you or the architect think that this is a superior design. I cannot see it. I'm never going to see it, and I'm never going to agree to it, even though I saw this design on almost every set of building plans I worked with. I never used it. I never used it. My dad never used it. And there's no way I'm ever planning on using it because it just doesn't make sense. And the reasons for that can be found in the other video. For those of you who just want a brief explanation, a lot of it has to do with making this notch here and then fastening the stringers to this plate here. And in some cases, I've seen a gap here, and I don't like the gaps. The gaps can cause the stringers to break. And something like this might work fine on a wood-framed floor where you can drive more fasteners through the stringers into the wood-framed floors, or even use framing hardware, where on a concrete slab, you can see where you're only going to be able to attach it to the base framing plate, not to two base framing plates like you would have seen in the previous example. So what about this design here? Is this something that might work better for you? You're going to get both of the framing plates, which is what I would like to see, plus a couple of notches that in your mind might prevent the stairs from sliding forward, even though these notches wouldn't be necessary if the stringers are securely fastened to the base framing plate. So something like this would make me happy and make those of you happy who believe that this notch right here is somehow going to work better than the very first example I provided in the video. And if that one seems like too much work, what about this one here? Install the framing plates like I would like to see them installed, and have a notch at the back of the stringer, providing us with another method that might work better than the second example in the video. You're going to be able to use two framing plates that you can use to attach the stringers securely to the foundation, and have your notch here to prevent the stairs from sliding forward, to prevent the stringers from sliding forward. If this is actually something you believe will happen, again, even though I've never seen it happen. And if you don't like that idea, what about this one here? Grab a huge piece of lumber and securely anchor it to the foundation. Don't just secure it in the front or in the back. Otherwise, you could end up with the board twisting and forcing one side of the stringer up. And that's probably not going to happen if you have enough base framing anchors to prevent that from happening. Next up, number 8. Here is another quick tip for those of you who are cutting your stair stringers and a section of the stair stringer breaks off of your $40 or $50 piece of lumber and you're not that hip on getting rid of it. And you don't have to. Simply put some adhesive on both sides that need to connect together, place it back on, then grab some small nails and reattach the broken tip back to the stair stringer. And I've done this hundreds of times with great success. And of course, you're probably not going to have this problem if you're selecting primo lumber, number 1 or a select grade of lumber for your stair stringers. However, there are a variety of other circumstances that could lead to this. And if you can save the lumber using this trick, then definitely use it. Next up, number 7. Here's another question from one of our viewers who was having a difficult time using construction standard lumber to lay out their stairway. And if the stairway needs to fit within a certain measurement, like 4 foot 7 inches or 55 inches, which is what we have here, 5 11-inch treads, then you might need to get a little creative with your materials, and even more creative if you can't resize some of these composite materials that might look funky if you rip them down. And that's exactly what we did here. We have an 11-inch tread from the front of the step to the back of the step. with 2 1/8-inch gaps in between. This is for a deck. This might not be something you need to do on the interior. So let's go ahead and take a look at the measurements, what we're dealing with, to make the 11-inch step work. So we had to cut the 2x6 down to 5 3/8 inches so that we could end up with an 11-inch step with 2/8 of an inch gaps in that step. However, if you have more room and the stairway can be a little longer, then lay out the stringers accordingly. So instead of using an 11-inch step, we're going to use an 11 1/4-inch step. And that's going to allow us to use construction standard lumber, 5 1/2 inches wide with an 1/8 of an inch gap, 5 1/2 inches, and then another 1/8 of an inch gap. And if your materials are a little shorter or longer, you will need to make the necessary adjustments before laying out your stair stringer to make sure everything is going to work properly. And there are a few more things you can do if you want to, you feel comfortable doing, and that would be to install everything tight. However, for exterior stairs, this doesn't always work out well. Another will be to add a nosing and then leave a gap, don't leave a gap, and then use those measurements when you're laying out your stair stringer. Now we're still at an 11-inch step for our stringer layout, even though we have a nosing that's projecting out 1 inch. And the last one on the list will be to use a full-length piece of lumber like a 2x12 or even a 2x14 ripped down, or a 2x14 where you would compensate for the measurement when you're laying out your stringers. And you can see here where the tread depth for the stringer in this example is 11 inches, and that's going to provide us with a 5/8 of an inch overhang. And you can see that better over here. Let's go ahead and zoom in over here where we have a 5/8 of an inch overhang, 10 7/8 inches over here with an 1/8 inch gap. And I would definitely recommend using a gap when you're working with construction standard lumber or other materials that could create a moisture problem, and then that could lead to termite damage or wood rot. I say could. Remember, there are going to be other parts of the stairway touching each other. You're not going to be able to do anything about, like where the tread connects to the stringer or where the tread sits on top of the riser. And next up, number 6. In my experience, this is probably going to be the biggest problem a do-it-yourselfer or someone who is just starting out learning about stair building is going to make when it comes to adding a nosing to the stair step. So let's go ahead and get started with a floor plan layout where we have 8 10-inch treads, 48 inches wide, and the stair stringer will look something like this, and use the same measurements we have for the floor plan layout. 10 inches, 8 10-inch steps will provide us with a stairway that will fit within 80 inches. However, if you make this step 1 inch larger, because you're planning on putting a 1-inch nosing on each one of the steps, when you're laying out your stair stringer, you're going to end up with a stair stringer that will not fit into the 80-inch measurement. You're going to have a stair stringer that will fit into an 88-inch measurement. 8 11-inch steps that will have an 11-inch depth, and with a nosing will have a 12-inch depth, but still have an 11-inch individual run for the stair tread. So we're not going to add the nosing measurement to the length of the individual stair tread. We're going to lay the stair stringer out in the same way we would if we had a stairway without a nosing. So again, we're going to have a 10-inch measurement here on the stair stringer, and we're going to have a 10-inch measurement for the finished step without a nosing. And if I want to add a 1-inch nosing and create an 11-inch long stair tread, a stair tread with an 11-inch depth and a 1-inch overhang, I'm just simply going to make the tread 1 inch wider. Instead of a 10-inch tread, I'm going to add an inch to it, the length of the nosing to the depth of the individual tread run, in this example, 10 inches. So again, I'm not going to modify the stair stringer for the nosing. And this is what a lot of do-it-yourselfers seem to do. I've seen it plenty of times and hope that you don't end up repeating the same mistake. Next up, number 5. Here is a tip that you can use to lay out extremely accurate stair stringers, and I've been using it for years. So you can go with the common method of just setting the framing square on the lumber and positioning it where it needs to be, and then marking it, and then sliding it over to the next layout spot. But I'm here to tell you that if you do this, unless you line everything up accurately, and sometimes the rounded edges on the lumber can create problems for you. So I'm not saying you can't do it, especially if you're a meticulous person. However, I do have a better way that will be faster and more accurate. And that will be to use stair gauges and then run a line over to the other side. And most of the time, your framing square is going to be marked on the other side. I don't have this framing square marked because I rarely need to use the other side in an example. However, on my framing squares that I use to lay out stair stringers, and I laid out a lot of them, I just simply had a mark on the other side, and I made that mark with a sharp knife. I just simply cut a gouge in at 11 inches, 10.5 inches, and 10 inches. And instead of worrying about lining it up with the front edge of the lumber that is usually curved or difficult to line up, you just simply line this line up here with the line you just made, and then work your way down the stairway. So not too difficult. And if you have your stair gauges attached in the correct position, you're going to be shocked at how accurate this method can be for laying out a stair stringer. And I like to work right to left. However, if you want to work in the opposite direction, just simply install your little grooves on the other side of the framing square and then work your way in this direction. Next up, number 4. In this video, I will show you how you can take a piece of paper and simply grab some measurements, scale them down, and then draw them on your piece of paper, and then measure the angle on that piece of paper, and then measure the line on that piece of paper to calculate your stringer length. So another way to do it if this is going to be easier for you. So let's go ahead and start with a run of 5 foot 10 inches, or the length of the stairway, and the total rise, or the height between the levels, upper level, lower level, where we're going to have 4 foot 1 inch. And for those of you who might do a little better understanding what the stair stringer is going to look like for these measurements, let's go ahead and fill that in, along with the length of the board we're going to need to lay out our stair stringer. This will be the minimum length for these measurements. And let's go ahead and zoom out here. So we're starting with this right here to calculate the length of the stringer. And if you're starting with this right here and you're not working with a set of building plans, you actually have the measurements, you can lay it out on your project. You can simply measure from this point to this point. And if you end up with 7 foot 6 inches, you can buy an 8 foot piece of lumber for your stair stringers. However, if you have a set of building plans or you're designing a set of stairs and the Pythagorean theorem might be a little too difficult for you, just simply break these measurements down. I'm going to use 6 foot and go a little longer with this measurement, and then go 4 foot for this measurement here. And all I'm going to do is scale down the length of the stairway. Instead of 6 foot, I'm going to use 6 inches. And instead of 4 foot 1 inch, I'm going to use 4 foot and 3/16 of an inch, or forget the 3/16 of an inch and just use 4 foot. And when I draw that on my piece of paper, I'm just going to come off of the corner of the sheet of paper. This is a 90-degree angle on the piece of paper. So if I come off 6 inches and then go up 4 inches, I'm going to get 7 3/16 of an inch. And then I'm simply going to change this back to feet. Remember, this was 6 feet and 4 feet that I scaled down to 4 inches and 6 inches. So I'm just simply going to scale this up from 7 3/16 of an inch to just a little bit over 7 feet. And I don't think you can get much simpler than that without using the Pythagorean theorem, or actually measuring the actual distance on the job site. And if that doesn't make sense, let's go ahead and take an example where we might have 7 foot 3 inches and 5 foot 6 inches. I'm just simply going to break those measurements down to a fraction because there are 4 3-inch increments in a foot. So if I had any measurement around 3 inches, I could use the 1/4 inch to scale down my feet to inches in the same way I could do it up here. 5 foot 6 inches would break down to a ratio of 5.5 inches. And if I measure the length on my piece of paper and it's around 9 inches, I know I'm going to need a 9-foot board. And I'm not about to suggest this is going to provide you with accurate measurements, but it's usually going to be close enough. Since I can't get a 9-foot piece of lumber, I'm going to get a 10-foot piece of lumber, providing me with plenty of room to lay out my stair stringers. Next up, number 3. In this video, I will provide you with a way to build a set of stairs outside using a riser support board, a couple of stakes, some screws. And even though this will not be the safest set of stairs you can build, I think it will be among the cheapest stairway you can build outside. So let's go ahead and get started by attaching our stakes to the riser board. Now, I'm not suggesting you're going to attach the stakes first. You're probably going to drive the stakes into the ground first and then attach the riser support board. And the stakes on the end can be even with the top. Any stakes located in the middle area here should be located a little bit lower because they could be a trip hazard, especially as the soil erodes. So keep that in mind if you're going to build a stairway like this. And you can use more screws if you want to, or even nails, whatever you feel like you need to use. However, your materials should be rot resistant, and maybe you might need to use treated lumber or galvanized zinc or stainless steel nails or screws. And you can simply start out by positioning a riser board at the bottom where you want the stairway to end, and a riser board at the top. And this might require removing some of the soil around the top riser support board. However, I don't have to do it in my model here. So the boards will need to be level. And I would suggest only attaching a few screws through the stakes to the riser board in case you have to move it. So do not add all of your screws because you might need to raise the riser board or lower it. And next up, let's go ahead and figure the total rise, or the difference between the lower level and the upper level, by using a straight board and a level, along with the length. And the length really isn't as important as the overall rise. And I'll explain a little more about that later on in the video. But it will definitely be helpful to get the overall total rise. And in this situation here, we're going to have 30 inches, and we are going to divide this number here until we get something close to 7 inches, or whatever you want the desired riser height to be. So in this case here, we're going to divide 30 by 4 to give us a 7.5, 7.5 inch overall riser height. However, I could always add another riser to give us 5 risers with a 6-inch rise for each individual step if I wanted to. And I do have other videos on that if you're looking for more information on how to calculate the overall total rise or run of the stairway so that you can create stair steps that will meet local building codes. And if you do not position the upper or lower boards, you could end up with uneven tread measurements unless you're going to build a stairway that is angled. And if the stairway is wide enough and meets your local building codes, you can do it. However, if you want to square everything up, then go ahead and measure from one of the corners, the inside corner here, to the corner over here, and make sure that this measurement here is the same as this measurement here. And if these boards are level and your measurements are the same, then you should end up with a square area that you can use to build your stairs. And I'll leave it up to you as to which board you want to move, because you could actually have a situation like this, and I went ahead and exaggerated it, but you could always have a square set of stairs at an angle. And of course that angle could be in either direction. So make sure that even though your stairway is going to be square, that the bottom or the top will be located in an acceptable position for you if you're ever going to build a walkway or something to this set of stairs. Next up, let's go ahead and check the riser height. Since we're using 2x8, that is 7.5 inches, we already have our established riser height. However, if you need to, now would be a good time to raise or lower the riser board at the bottom or the top if needed to create the individual riser height for your stairway. So here we have 7.5 inches measured from the top of our riser support board to the lowest level or the lower level of our stairway. So we have a lower level and an upper level. And if you remembered earlier, I suggested that I was going to provide you with an easy way to line everything up here. Well, here it is. Just simply take a 2x4, a straight board, and mark it at the top of the front of the upper riser and the top of the front of the lower riser. And it really doesn't get any easier than this, especially if you have a straight board here that you're going to be working with. If this board is not straight, you might consider using a string instead. And to do that, you could just simply put a nail or a screw up here, a nail or a screw in the face of the riser, and then attach a tight string to that. I do have another video on that, on how to use a string to create a straight line, if you need more information on that. Then we're simply going to measure the distance from here to here and then divide that up into the amount of steps we're going to have. And in our example here, we're going to have 3 steps. So we're going to divide this up into 3 sections. And yes, we're off a 1/16 of an inch here, and that should be okay for our stairway. So again, 3 equal sections. And if you're using a string, again, you're just simply going to measure from here to here and divide this area up into 3 sections, and then use a measuring tape to measure from this point to this point so that you can locate your riser support boards. So not too difficult. You're going to use this board or this measurement and then set this riser support board even with this edge of the string or this edge of the board. Drive a stake into the ground, put 1 screw into it, and then move the board over to the other side, or just simply grab your measuring tape and measure from this point to this point, and then make sure that the board is level, and then go up to the next board. So really isn't a difficult stairway to build, especially now since I provided you with some general installation instructions. And now you can go ahead and remove some of the dirt and backfill the areas that need to be backfilled. You can add and remove whatever soil you need, or you could always install some gravel, some other types of fill materials. I do have other videos about this type of construction. You can always check those out too. And if you do build a stairway like this, there's a very good chance that the soil is going to settle or get blown off of the stairway. You might need to refill these areas or shape the sides here so that the soil isn't going to be falling into the stairway. And of course, you could always use some type of a block to prevent the soil from coming into the stairway also. So there you have it, the basics for building something like this. And for those of you wondering why I extended this past, well, something like this might provide you with a way to prevent soil from falling down here into this area here and messing up the width of your stairway. Now, I do not know if this would be an approved stairway by your local building department, or if it will be a safe stairway for you to install on your property. So make sure that you check with your local building authorities, because soil, whether it's wet or dry, can be slippery. Same with gravel. So keep that in mind when you're planning to build this type of a stairway. Next up, number 2. This will be the first video in a series of videos. I will be creating a playlist. I will put a link to that playlist in all of the videos, and if for some reason you don't have a link to it, let me know, along with letting me know if there's something in the series that I missed. And all of your questions, leave those in the comment area if you have them. So let's go ahead and get started with our first project. We're going to be using a straight 1x12. We're going to set it on top of the steps like this. And we could always use some tape to hold it to the wall if that's going to work. And the first thing we're going to do with this suggestion here is check to see if there are any gaps at all between the bottom of our board and the corner of the tread and the riser. And if there are any gaps at all, then we're going to have to use a different video. Even though this method can be used for both, we're going to focus on straight steps, straight lumber, and create a finished straight skirt board. So the first thing I want you to do is set your framing square on top of the tread, butt it up against the riser. And even though I don't have the inch marks over here, you can use yours or simply make a mark on the framing square like I did here. And it wouldn't be a bad idea to grab a piece of paper and a pencil and then go ahead and check all of the steps, including the first one down here. Set the framing square like we have it here. On each one of the steps, write down what the numbers are, and if they're all the same, great. And you can go ahead and proceed with watching the rest of the video. If they're different, this method might not work for you. And there are a variety of different ways you can do this. We're going to use a level and line the point of the framing square up with the point of the tread and the riser. And then we're going to use this to lay out our first step or our first notch that we're going to need to make in our skirt board. So here you can see where we're making a mark that would line up with the mark we placed on our framing square at the top, and then we're going to do the same thing at the bottom here. And then after we have the framing square in the position that we need, we can go ahead and draw the lines that we're going to use to cut out our notches for the skirt board. And it wouldn't be a bad idea to connect the two lines here together with a straight line, or a line that's going to be parallel to the top of the skirt board. And if you go to connect the two lines and they're off a little bit, then you might have a problem. And we'll need to watch another video in this series to solve that problem. Next up, let's go ahead and set the framing square into the next position. And you can see here where the marks are in the same spot as they were on the previous step. Then we're going to go ahead and reposition the framing square. And of course, you can see here where we have laid out the rest of the marks we need. And of course, after we cut out our notches, let's just go ahead and give you a couple of different views of our board here. And after you have done a couple of these, you might be able to lay them out on top of a couple of sawhorses, or at the very least, you'll be able to take the board over to and set it on top of something so that you can cut the notches out. You will not be cutting the notches out with the skirt board still up against the wall, like we have in our example here. After that, you know what to do. Slide it into position. And if everything works out okay, you shouldn't have any gaps in between the risers and the treads, and should be able to finish off the floor trim however you want to. You can see here where we are using this method here to connect the baseboards to the skirt board at the bottom and at the top. And last on our list, the number one video. A few days ago, I was watching a video where the individual suggested that you could solve your stair squeaking problems by installing a screw. If you have carpeting, you can just simply drive the screw through the carpeting. And they're right, I've done that before. However, by the time you finish watching this video, you're going to have a little better understanding of exactly where that screw might need to be positioned. And I believe the individual also suggested that if you have access to the bottom of the stairway and you have a gap between the bottom of the tread and the top of the stringer, that you could just simply drive some wedges or shaped pieces of lumber like we have here into this area, and they're right, you can usually solve this problem by preventing the treads from moving. Keep in mind that most squeaking stairs are going to have something to do with the lumber moving. And if that lumber is moving here, you're going to have a noise from the back of the tread, front of the riser. And that might require some type of a fastening device like a screw to prevent the tread from going up and down and rubbing on the front of the riser. And this is going to happen in the area between the stringers. Most of the time it's not going to happen right here. However, it can happen there. Got to point that out, especially if you have a gap. The gaps are usually created by the stringer shrinking. And if you don't have any carpet, you can usually find the stringer and drive some screws through the top of the tread into the stringer to solve this problem. So there you have two ways to solve the problem. And as the individual suggested in the other video, is that we can use a screw. We can just simply install the screw through the carpeting and then simply move some of the fibers of the carpeting over to cover up the top of the screw. Now, here's the problem I have, and it's probably going to be the problem you're going to have, is that you don't know where the stringer is going to be located. Is it going to be located exactly in the center, or is it going to be off just a little bit? And to give you a little more insight on this, let's go ahead and remove the carpeting and then take a closer look at the padding. The padding is usually going to wrap around the front of the tread, and you're going to have carpet tack strips located over here. And the carpeting over here is either going to continue and roll up, or it's going to be cut in sections where you're going to take the back of this section and tuck it into this area here. Same thing down here. You're going to take the bottom of this piece and that will go in this area. So we're going to kind of take both pieces of the carpeting at the top and bottom and then shove them into this area. And again, I'm not about to suggest this is what you're dealing with. I'm just trying to provide you with another possibility. So if we don't know exactly where the stringer is going to be located, all I would simply suggest is that we measure the stairway and start in the center and hope for the best. However, if we do not hit the stringer, or we don't know what it feels like to hit the stair stringer because you've never done this before, then I would simply suggest to install a screw in the center, and if that horrible squeaking noise goes away, then you hit the lottery. However, if it did not go away, then you're going to need to install the next screw either on the left or the right. And I would recommend going about 3/4 of an inch over in either direction. But you don't need to install two of them. We're going to just simply do one at a time. And you can also remove each screw after the squeak didn't go away also. And just simply move it over a little bit. Because here's what's usually going to be happening if the squeak doesn't go away. It just simply means that you missed the stair stringer, if there actually is a stair stringer. Another thing you're going to need to be aware of is that you might have a stairway without any stringers located in this area here. And another thing you will need to be aware of is that these screws will need to go a little further down. You don't want to have the top of the screws even with the top of the carpeting, because that could create a trip hazard. And don't be afraid to have the screws go into the top of the tread a little bit further, because if you do find the stringer and this somehow pops out, you can install another screw on the other side. The main thing you want to be aware of is finding the stair stringer and closing the gap. You want to pull the tread tight up against the top of the stair stringer. And then either removing the screws that missed the stair stringer or adding a few more screws once you have found the stair stringer. And as long as the tread is no longer moving, it's not going up and down every time you step on it, you don't really need to worry about any of the screws that didn't hit the stair stringer. And the last thing I want to make you aware of is that stairs wider than 36 inches might have two stair stringers located in between the stringers on the outside. suggesting that you're not going to find it with a screw in the center. You're not even going to be close. So again, stairs that are wider than 36 inches or stairs that are definitely wider than 40 inches. It might be using 4 stringers in a situation like this instead of 3 stringers in a situation like this. So the moral of this story is that you're not always going to be able to just grab a screw and drive it through the carpeting, especially if you're dealing with a design that doesn't have any stair stringers in the center, or a stairway where the stringers were not installed in the center and might be off an inch or more on either side of the center of the stairway. Or you might be dealing with a stairway with more than 3 stringers.